This time we got a clean slate packet tracer file. I have not configured any of the basic stuff so that we can exercise a little bit together. I'm going to start from router 1 and do the first two tasks at the same time. I'm going to go in increments, so router 1, router 2, 3, 4, 5, and then 6, and then we will go to the third task, which is configure IP addresses on PCs, and then once we're done with that, we will focus on the routes. So let's get into router 1. Command line interface, enter, enable configure terminal, and then the first thing I want to do is configure the host name, which is R1. And then let's go to the interfaces. The first one I'm going to configure is this Gigabit Ethernet 010. It's a fiber optic link. So interface Gigabit Ethernet, Gigabit Ethernet 0/1/0, and then IP address is going to be 3001. The mask is /30, so that's 255.255.255.252. And then we want to switch it on with no shutdown. Exit that interface and get into Gigabit Ethernet 0/1. That's this link over here. IP for that is going to be 1001 with the same mask, and then no shutdown. That's it for router 1. Let's go to router 2 now. I'm going to look at this diagram over here to make things easier. So enable configure terminal, hostname R2. And then let's first configure this interface, Gigabit Ethernet 0/1. So interface G0/1. IP address on this side is going to be the next IP address, which is 1002, and then /30 mask, and then no shutdown. Let's move on to the other interfaces. Interface Gigabit Ethernet 0/1/0. That's this link over here. The IP address for that is going to be 2001.255.255.255.252, and then no shut. And then interface Gigabit Ethernet 0/0. That's this link over here. Let's allocate 4001 for this interface, and then no shutdown. And then that's that for router 2. Let's move on to router 3 now. Enable configure terminal, hostname router 3, IP address 2002. We used 2001 on router 2, and we're going to have a /30 mask, so 255.255.255.252. Whoops, I haven't entered the interface, so 010, and then I'm gonna copy this because I'm lazy. Enter, no shut, and then moving on to these interfaces where we have switches connected. Those are Gigabit Ethernet 0/0. IP address there is 10.1.0.1. This is going to be the gateway for any PC that connects to this switch right here. And the mask this time is 255.255.255.0 because it's a /24 mask. No shutdown, of course. Interface Gigabit Ethernet 0/1. IP address 10.2.0.1. /24 and then no shut. Moving on to router 4. Enable configured terminal, hostname R4. Let's start from these northern interfaces. Interface gigabit Ethernet 010. That's this fiber optic link. We'll use 3002. No shutdown. Moving on to gigabit Ethernet 0/0. IP address there 4002.255.255.255.252 and then no shutdown. And then the only ones left are these two serial interfaces. We can see here that router 4 should be a DCE device. If I hover over this, I'm hovering in the Word document. Okay, let me do it here. If I hover over this link, I will see a clock on this side. That seems to be right. So this side should dictate the clock rate. We're going to configure the maximum clock rate. So interface serial 000, that's this one over here. I'm going to say clock rate 4 million. Oh no, I added a 0. Okay, so 4 million. IP address 5001.255.255.255.252. No shutdown, and then interface serial 001. Clock rate 4 million bits per second. IP address 6001/30. No shutdown. Only 2 routers to go. Router 5. Enable configured terminal, hostname R5. Interface serial 000. IP address 5002.255.255.255.252 and then no shutdown. And then similar commands on router 6. Enable configured terminal, hostname router 6. Interface serial 001. IP address 6002.255.255.255.252 and then no shut. At this point, we have configured all of the interfaces and gave them IP addresses. Let's configure IP addresses on our PCs. Luckily, we only have 2. So it's going to be 10.1.0.2, for example, on this PC, 255.255.0. And the gateway is the IP address we allocated for this interface right here on router 3. So let's put that in, 10.1.0.1. On PC2, it's going to be 10.2.0.2. Make sure that the mask is /24 and that the default gateway IP is 10.2.0.1. Now we need to figure out on which routers we can use default routes. It's obvious that we can do it on router 5 and router 6, so let's configure them right away. On router 5, I'm going to create a default route, so IP route, and then all zeros, which means any network, and then all zeros, which means with, so any network, this is any network, and this is any network with any subnet. And then we can name the next hop address or the exit interface. Let's name the next hop address here. So it's going to be 5001 in this case. That's the address we configured on router 4 on this interface right here. And that's it for router 5. Whenever we send a packet from router 5 to anywhere, it only has one interface, so it will send all of its traffic north. Let's do the same for router 6. Enable configure terminal, IP route, and then all zeros. And then this time we can use the exit interface 001. This warning we can ignore. So that's it for router 6. Now, the less obvious router we can configure with a default route is router 3. Let's analyze router 3 for a second. Here we have 3 links, out of which these 2 little local area networks are the definition or a textbook example of a stub network. We do not expect another network to be connected to this network. It's an end user network, so we expect all of the packets that come from this network and want to go out into the rest of the network, they will all go through this 1 gigabit Ethernet interface. If you look at all the different possibilities, if PC1 wants to send something to router 6 or router 4 or router 2, doesn't matter, those packets will always go through this link right here. So that is also a good candidate for a default route. Let's configure it on router 3. Enable configure terminal, and then IP route, again all zeros, and then we will use the exit interface again, which is gigabit Ethernet 010. Now on to the rest of the pack. We actually only have 3 other routers to worry about, but there's lots of other networks that they need to reach, so let's get going. Okay, I'm going to need a full topology here with all the networks. I'm gonna set this like this. Enable configure terminal. And now let's look at all of the networks that router 1 needs to reach. I'll do it in order, so we will add routes for 2 and then 4 and then 5 and then 6 and eventually 10.1 and 10.2 networks. So let's start from 2. IP route to network 2000. That network's subnet mask is /30, so that's 255.255.255.252. And then I need to tell router 1 through which interface or through which neighbor it can reach that network. And that will be interface gigabit Ethernet 0/1. This annoying warning, by the way, will be more clear when we do point to multi-point stuff. But right now, all of these networks are point-to-point links, or all of these links, sorry, are point-to-point links. So we are good. We can ignore this warning. It's a bit annoying, but that's life. And now let's add a route for network 4000. So I'm going to say IP route 4000. Mask is the same. And then we can reach that network through 2 different routes. We can go here and we can go here. And this is actually the perfect opportunity for me to show you this AD parameter. So this will be our first route to network 4. And it's going to be through interface gigabit Ethernet 0/1. And let's say we prefer to go through the fiber optic link. So we will give this route an administrative distance of 20. And then we will give this other route, which is gigabit Ethernet 0/1/0, an administrative distance of 10. Again, the lower the AD value, the better. adding routes for networks 5 and 6. So IP route 5000, 255, 255, 255, 252. Again, I'm going to use this fiber optic link to get there. And then it's pretty much the same for network 6. And the only routes left to add are these 10.1 and 10.2 networks. So IP route 10.100, mask is /24, so 255, 255, 255 is 0. And to get there, we should use this link over here. So that's gigabit Ethernet 0/1. And then I'm going to use the up arrow and just change the second octet here. And that's it. To see all the added routes, I'm going to use the command do show IP routes. And this is the complete routing table for this router. If you are new to this might be a bit confusing to read. So first, the router is showing you this /8 mask, which would be the mask for 1000 if we followed IP addressing classes. It would belong to the A class. And then for the directly connected networks, you will see the IP address of the interface, but also the network address. What we want to focus on are these S routes, because those are the static routes that were configured by an administrator, in this case, us. Okay, so let's move on to router 2 now. Router 2 is directly connected to 3 networks, so 1, 2, and 4. We need to add routes to 3, 5, 6, and these 2 networks over here. So let's get started. IP route 3000 with mask /30. There are 2 ways to reach this network. We can go to gigabit Ethernet 0/1 and gigabit Ethernet 0/0. Let's go with 0/0, for example, it doesn't matter. And then it's quite similar to reach 5 and 6. So I'm just going to edit the previous command and then do the same thing for 6. And then to reach 10.100/24, I'm going to use the gigabit Ethernet 0/1/0 and then do a similar thing for 10.2. On to router 4. Enable configure terminal. Router 4 is actually connected to the most networks in this topology, so we need to add 4 routes. IP route 1000/255/255/255/252, and we will reach that through gigabit Ethernet 0/0. And then I'm going to edit the previous command for network 2 and then do pretty much the same thing for these 2 networks connected to router 3. 10.100/255/255/255/0, gigabit Ethernet 0/0. Same for 10.2. And you might notice here that we could have used the default route here as well, but we do have an alternative route here, and I encourage you to play around with it. So I wouldn't use a default route here because there are 2 outgoing interfaces we could use. Okay, now let's test. As always, we will use ping. Let's go, for example, from PC1 to PC5. I was starting to get worried there for a second, but the ping is successful in the end. We can use simulation mode a bit later. Let's try some other things as well. So since there are lots of hops in this network compared to our previous exercises, we are going to have more failures before we get a success. Let's continue to test. I wanted to make sure to fill those ARP tables before I do a simulation. So let's see what happens when we send a packet from PC1 to router 5, for example. So we're going to get ICMP right away. The reason we had so many failures was because ARP tables were empty in the beginning. So let's start. This packet goes to router 3. And let's see the decision process. So the packet gets into the layer 3 of this router on the incoming interface. And the first thing we see here is that the router is looking up the destination IP address in the routing table. Don't be confused by this. This is Cisco Express Forwarding Table. It's a routing table. For now, okay, let's not comment on it. Cisco wants to put its name everywhere. So the next layer or the next step in this process is that this router finds an entry in the routing table for the destination IP address from the incoming packet. And then this is actually very important. So this router doesn't really focus on the destination. It only focuses on the next hop IP address. So it only cares about getting rid of this packet as soon as possible. So it looks up the next hop IP address to see if there are actually any neighbors for this router that have that IP address, and it finds that there are neighbors here called adjacencies, or rather, let me correct myself, there is one neighbor. You cannot have several neighboring routers with the same IP address. So it finds that there is this IP address in the adjacency table, and then of course you need the MAC address to send that out, and that's all we care about. So we've seen what the process looks like inside the router. Let's look what happens next. So the packet goes to router 2. Router 2 pretty much goes through the same process and then forwards that packet further. So router 5 gets the packet, and that's where the source IP and the destination IP addresses switch, because now this router has to respond to the initial sender and send that packet back. Of course, router 5 has a default route, and I don't think I've shown you on these routers which have default routes what that looks like. Let's take a look. Enable show IP routes, and here it is. We have the 5000 for the directly connected network, and then we have this static route with an asterisk which tells us it's a default route. Okay, that would be it for this exercise. They will continue to get more complicated and more interesting as we move forward, so see you in the next one.